Dr. Karnik with New Age Science Academy. And in today's session, we are going to be talking about intermolecular forces. We are going to be looking into what are intermolecular forces. We are also going to be looking into why are these intermolecular forces important. And then we are going to look into the different kinds of intermolecular forces and how these forces affect different properties of a molecule. So let's first start with intermolecular forces. As the name itself suggests, these are the forces between two molecules. And just to demonstrate this, I'm going to be using this set of ping pong balls as different molecules. Remember, these are molecules, not atoms. So each of this molecule has many atoms inside it, right? So we are looking into two molecules here. And let's say we are looking into a liquid phase. Okay, so in this liquid phase, we have these molecules which comprise the liquid. Okay, these molecules are going to have certain forces of attraction between them. So in this case, here, if the force of attraction is strong between these two molecules, then it is going to be difficult for these molecules to get away from each other and escape. Now, when does this situation happen? Usually when you're talking about liquids, you start heating up a liquid. The heat energy gets transmitted to the liquid, which enables the breaking of these intermolecular forces between the molecules, and these molecules, that energy is used to move this molecule from a liquid form to a vapor form or a gaseous state. If the intermolecular forces are going to be strong, it's going to be difficult for these molecules to escape from a liquid phase to a gas phase. In other words, I will have to provide a lot of energy for these molecules to escape into the gas phase. Which also means that for this particular molecules of the liquid, the boiling point of that molecules of that liquid is going to be very high if the intermolecular forces between these are going to be stronger. Now, the same concept applies if these molecules were a part of solid. And we know that as we start heating up solid, the energy gets transmitted to these molecules, and the intermolecular forces between the molecules get broken down, and these solids now have more movement happening here, and now it gets changed into a liquid phase. We already know how state of matter works, right? When it is a solid, they are more rigid. There is not much movement happening here. When it comes to a liquid, the molecules are further spaced apart, and therefore you are going to see the fluid nature of any liquid. And then when you are talking about a gas, you know that these molecules are further spaced apart, and therefore gases are going to be moving more than what you see with liquids or with solids. So in other words, when you are talking about movement of a solid to a liquid, or changes in the phase of matter from a solid phase to a liquid phase to a gas phase, the intermolecular forces are going to be playing an important role into how much energy should we supply to this particular phase to change into another phase. So let's look into the different types of intermolecular forces which are responsible for holding these molecules together.